Hi there, everyone. It's Hugo Bown Anderson here for Rasa. I am super excited to be here today with Daksh Vashneya. I'm sorry, a senior product manager at Rasa. What is up, Daksh?
Amazing. All good. Excited to be doing this, Hugo.
Man, I'm so excited because we've been telling stories around how to build conversational AI, which we've been doing for a long time with LLMs now. But we've been using in a lot of our conversational AI assistants. We've been using a lot of vendor APIs. But what you and the team have built recently is a recipe for building fine-tuned conversational agents using small self-hosted models. And today we'll be demoing how to do it with Llama 3.18b. Is that correct?
It's absolutely exciting. Yes, that's absolutely correct. We've been working on this feature for a while now, and it is so exciting to finally give it in the hands of the users with the latest release of Rasa Pro. And yeah, I'm gonna save all the details for the actual live code along. And yeah, let's just
Incredible. Well, I would
start.
just like to welcome everyone to this live stream. For those just joining, I'm Hugo here with Daksh from Raza. We're so excited to be working with fine-tuned small self-hosted models, which, as you'll discover, are great if you're interested in your own data privacy and also reducing latency. And as we know well, and we'll see again today, time is money. And we've had that saying for a long time, but it literally is when you're talking about automating customer assistance and that type of stuff. So please introduce yourself in the chat on YouTube. Let us know where you're calling in from. I'm actually in Australia currently. And Daksh, where are you?
I'm in India right now, in
Yeah,
Bangalore. So
amazing. So
already
we're
we've got two continents covered.
exactly we're already international and spread across continents. So let us know where you're calling in from, and also what you're in. Do you work in data science? Oh yeah, Mohammed says India represent. So awesome. So yeah, let us know where you're calling in from and where you work and what your interest in such things is. But without further ado, what I'm going to do is start by showing a few slides, and then we're gonna just to set the scene and set the context, and then we're gonna jump in and rock and roll and build some models. So, um, as I've already said, we're here to talk about. Can you see my screen, Dutch? Great.
Yes, I can.
So we're here to talk about building a cost-efficient conversational AI with fine-tuned models. And today we'll be using Llama 3.18b. As I've already said, I've introduced us. I'm Hugo. I'm here with Dutch. And the even more exciting thing is we're going to do this live stream, and Dutch just pinged me a couple of hours ago saying, I've put the instruction tune or the equivalent of the conversation data set on Hugging Face, and I'll share that link in the chat after I've gone through these slides. And we've also put the fine-tuned model that you can use for the command generation, and we'll get to what that means in a minute as well. So you can start playing around with this stuff today. I also just wanted to mention we're having our Calm Summit in New York City at the end of October, and if you'd like to join, please go to calmsummit24.com and use the promo Calm Summit 30 to get 30% off. And we'd love to see you there. For those who have some experience with Rasa, or if you've never tried it before, I do encourage you to check out the quick start. What we have is a code space for you in GitHub. That means you can play around with building assistants without setting up any infrastructure yourself locally. You can go to bit.ly/rasa-quick, or use this QR code to do that as well. And let us know how you go there. Um, and on top of that, something we'll be talking about today is we've been building assistants, kind of comparative assistants in the space to see how each performs across a variety of metrics. And something we discovered is that using the paradigm of Calm, and we'll see why we were able to cut costs by up to nearly 80% by leveraging just a bit of clever business logic. And we'll see what that means. Please do check out our blog post on this at bit.ly/calm-AI or this QR code as well. Um, Before jumping in, Dutch, I'm wondering if you could, because we're not building these things only for funsies. Don't get me wrong. I love chatting with LLMs and love chatting with conversational AI. But we're building them and helping people build them to serve real business needs as well. So I just wonder if you could tell us a bit about kind of why we're building them and what KPIs for measuring assistance are.
Yeah, absolutely. And I think uh, that's exactly how I like to think about this, in the sense that um, you should be very, very clear about the KPIs for your system that you're building, right? Be it any system. And when you're thinking about a conversational AI system, which you're about to, let's say, put in production in front of your end users, um, couple of things that just stand out as critical to measure is, for example, how many or percentage of interactions that you've been able to contain within the assistant and not have a human agent have to help the end user, right? And so you can essentially you can put all of those conversations as tag them as successful conversations, right? So just measuring the percentage of successful conversations is absolutely important, because you just need to know how much is your assistant actually helping with the automation that was your first goal, really, right? And then, I mean, of course, I mean, if any one of you have tried talking to, chatbots, firstly, but then also just human support agents, right? Um, all of us just don't like to be, talking on the phone for whatever, like an hour or so. I was just on a call with a travel booking vendor yesterday, and I was basically on a call with them for rescheduling my flights for almost an hour. And that is such a time sink, both for me and for the business who had this customer support, right? And so part of the reason why I was there on for an hour was because there was so much of back and forth, and then I had to, essentially call them up multiple times. And so a very important metric is first contact resolution, which means that how many percentage of times, what's the percentage of issues that you've been able to resolve in the first interaction itself, which effectively reduces the total amount of resolution time for your end user, right? And finally, I mean, everything is cost driven, right? I mean, one of the goals is to bring down your whole business costs. And so you just don't want to burn a hole in your pocket when building a chatbot, right? And so measuring the cost per conversation is such an important metric that is often not the primary metric, but very, very important when you think about scale at which you would obviously want to serve your assistants.
Yeah. Really appreciate all that context. And I think along the same lines, and to be clear, I mean, each token is relatively cheap with vendor APIs, but boy, can it add up pretty quickly. I mean, most of us now have been in situations where we've looked at our, bills for whatever it may be and be like, oh, I should have turned that off. But when thinking about these types of metrics, what we have seen, and this is, you can go to our blog post about this, is that in terms of being effectiveness across a number of these metrics, Calm does outperform a lot of other different types of assistance. And one reason for this, what I wanted to say, this is a figure from LangChain and LangGraph's Build a Customer Support Bot tutorial, where essentially with a lot of these more React style agentic approaches, you're talking to one giant brain, one giant assistant, and then it delegates out to all of these different things, and you get extremely long prompts in the end. And it's essentially a variety of unstructured skills that are being leveraged a lot of the time. And so the way Calm has approached it is somewhat different, whereby, and this is what we'll see, instead of having an open-ended set of things that can be done, you have a discrete number of skills which you write as flows in your business logic. And what the LLM itself does is it's actually a command generator that once you put a prompt in, the LLM will figure out what the intent of the user is, and put them in any number of in any one of these flows. Let's say, so we'll be working with a travel assistant. Let's say the user wants to book a hotel, then there'll be a booking hotel flow. And the business logic will be like, you need to fill in a certain number of slots. What date do you want to check in? What date do you want to check out? Which hotel do you want? Which city? This type of stuff. So these slots will be have the assistant will ask questions, which allows these slots to be filled and be validated in a certain way and respond accordingly. So what it means is that there's a directed conversation in order to fulfill certain criteria, and we can't get out of any of these flows. So it can't, for example, transfer a negative amount of money, or these types of things, or try to leverage a skill that doesn't even exist. And we all know that LLMs due to their probabilistic nature, are so open-ended that they'll say they can do things that they can't. I mean, you can ask ChatGPT to book a hotel for you, and sometimes it'll be like, oh yeah, I did that. And you'll be like, did you really? And it will say, oh no, I was just simulating a conversation of someone booking a hotel because I thought that's what you wanted, right? So those are the types of things we very much want to avoid. Now, we can do this with even smaller models, which is what we're here about today. So we've shifted the axes slightly here. So maybe Daksh in just a minute or two, because we want to jump in soon. And I've waxed lyrical, I apologize. But if you could talk us through what these axes are and what's happening up here.
Yeah, absolutely. So the y-axis over here is like the accuracy of your model of the LLM that you're trying out, and then and that is always a functional metric of your system that you want to measure. And then on the x-axis is essentially your non-functional but system metrics around throughput and cost, right? And so it's an age old, I mean, it's a principle that you're always going to have some trade-off between accuracy and throughput and cost, because you could horizontally or vertically scale systems, right? But you can only do it to a limit, right? And so what we found is that, look, I mean, GPT-4 is the king of models, even still. You go on to benchmarks, like the 2023 version of GPT-4 is really the best one right now.
Mm-hmm.
And so, but it's really poor on its costing and the throughput that you can get from there, right? And so you really need to come down towards smaller models in order to gain that efficiency on throughput and cost.
Mm.
However, you see that you actually work with, for example, Llama 3 8 billion out of the box, its out of the box accuracy is not going to be good because it is a small model which was trained, which does not have that capacity of the knowledge that, for example, a GPT-4 has. However, every time when you're building an AI system, it's important to also assess, are you using the LLM for the task that you want it for, right? And so if you think about Llama 3 8 billion, it is trained on a generic text completion task, essentially, right? But that is not the task that, for example, a Calm assistant needs, right? If you folks are familiar with a Calm assistant, there's a specific task of command generation where a user's input is broken down into what are known as commands. And so what we've found is that if you fine tune a Llama 3 model, a Llama 3 8 billion model on this specific task, you can basically get the similar accuracy as GPT-4 while staying at the same throughput and cost efficiency as an 8 billion model out of the box, right? And so really what's desired is you want more and more models in that quadrant where you've got that fine-tuned Llama 3 8 billion, right? And that is the end goal really that you
Yeah.
want to.
Absolutely. This is super cool. And it reminds us of a lot of other things that given good small amounts of data, you can give like, depending on the task, give a BERT style model 400 data points and it can perform as well as GPT, whatever, right? So it's a fascinating space to be working in and thinking about at the moment. Of course, there are forces that want us to believe that these one big models, a lot of capital wants us to believe that as well, but I don't want to get too neo-Marxist on anyone here. What I do also want to clarify, I did say time is money. I mean that very seriously. And we can link to a few of these things in the chat, but not only does latency affect user engagement, but companies such as Amazon has found that every 100 milliseconds of latency will cost them 1% in sales. You think about how much Netflix uses machine learning and AI to optimize latency. That's for a very important reason, because if they're not streaming as fast as they can, they'll be losing money. So what we're going to see today is that this type of model, it reduces latency from, so what we see is this is our Calm LLM. These are a couple of other Calm models. And then we see when self-hosting, the latency goes down. So these are box plots where the median's there, 75th percentile there, and you can see the data points up there. These are certain types of conversations the travel assistant does where it leverages a bunch of skills. These are the happy path conversations where the user just wants to do one thing, like book a hotel or something along those lines. We haven't been able to put LangChain and LangGraph on these plots because the latency is so much higher. But without further ado, we did come here to code. So perhaps, Daksh, you can tell us a bit about the recipe that I've visualized here, and then we can jump in to look at the code itself.
Absolutely. Yeah. So so yeah, I mean, let's maybe initially just go through a conceptual overview of how the recipe works, and then I'll jump into the exact steps that you need to do. And so our basic hypothesis behind the recipe is, or behind the fine-tuning recipe that we've built, is that if you folks are familiar with like a concept called model distillation, essentially, or knowledge distillation, where the real concept is that you could have a very strong teacher model, for example, GPT-4, right? And you can use the outputs of that model to train a smaller model in a way to really distill its knowledge into that smaller model, right? And that is the core premise on which this whole recipe works, right? And so when we put across this premise, the problem statement for us was, okay, how can we build out a kind of a semi-automated pipeline, which can, for example, take as input a bunch of sample conversations, pass them through an assistant, a CALM assistant that is right now enabled with GPT-4 as the command generator, get the outputs of that get the command outputs from the LLM, right? Construct a data set where you've got prompt command pairs, right? And essentially ingest that into your the training of a smaller model, right?
Mm.
I've said a lot of things over here, and I'll walk through each one of them now specifically, right? And so let's start exactly with the input side, right? So what I said was, what we want is we want a bunch of sample conversations, really, that you want your assistant to be able to process, right? And at this moment, actually, Hugo, can I share my screen?
Absolutely. So you, one sec, actually, you should have permissions now to do so.
Awesome. All right. Is my screen visible?
Yep,
Yep.
can see you. Looking great.
Amazing. Awesome. So yeah, I mean, as Hugo mentioned, we so for this code along, we're going to use the travel assistant. For folks who are familiar with the benchmarks that we've been putting out in the previous weeks, you folks might have seen this repo
And
where we've
I'm going to drop all these links in the chat. I wasn't able to while I was talking, of course. And I'm going to put in the links to the fine tuning recipe and all of that as well.
Awesome. Okay. So yeah, so this is the travel assistant, which essentially right now built helps you with three skills. One is booking and changing your flights, booking a hotel, and booking a car rental, right? And so we'll be taking this assistant as our test assistant. And so coming back to the recipe, I mentioned that as input, we want a bunch of sample conversations, right? And so I'll just very quickly go through one sample conversation that this assistant can right now handle, right? So if you go through this, so essentially this is the format in which you write end-to-end conversations in Rasa, right? Where each step of the conversation is a user-bot pair, right? And one user bot pair can essentially be called as one turn of the conversation, right? And so over here, what's happening in the conversation is that the user is just trying to book a car. It's giving all the details where they want to book a car. And actually, when the user is asked for a particular selection, they take up the luxury one, right? But then all of a sudden they try to change their mind and well, I mean, they want to save some money and they change their selection to the economy one, right? And the assistant should be able to handle that change in request, right? And proceed with the booking of the car rental, right? Now, this is just a sample conversation, essentially, right? Um, and so if you think about it, if you want your fine-tuned model to work well for this assistant, you want these sample conversations to be as good in coverage of the skills of your assistant as much as possible, right? Which means that it should be you should have a good number of conversations written for um, every skill that your assistant should handle, right? And so to help with that, the first thing that you do is once you've written your sample conversations in your end-to-end format, we've built what is known as a end-to-end coverage tool, essentially. And at this point, I'll just switch to my terminal, right? So I have my assistant over here, which I showed, right? And I'm inside my specific assistant, which is the CALM assistant using a GPT-4 LLM right now, right? We're going to use this assistant to build a fine-tuned model and then use it within our assistant, right? So the first thing that you can do is essentially run this command. So over here, what this does is it basically runs your sample conversations through your assistant, right? And assesses how much do those sample conversations cover the skills of your assistant. And a proxy for understanding or doing this is basically going to the flows of your assistant and checking which steps of the flows are actually covered, right? And so this one is a bit of a time-taking process. So I'm going to run this in the background for now. Um, and also before that, actually, before doing anything, I mean, if you all are familiar with Rasa, the first thing that you usually essentially always do is just run your action server, right? So let's first start the action server over here. And on a separate terminal, I'm going to run my coverage tool, which should be running in the background now. But just to save time on the stream, I'm going to skip to the output and show you how does the output of this coverage tool look like and how do you interpret it, right? So once the whole coverage tool finishes, right, you're going to see essentially this kind of a table on your screen. And this is essentially trying to tell you what steps of your flows are covered by the sample conversations that you've just input into the tool, right? Treat this as essentially if you folks have worked with, for example, PyTests and tools like code coverage tools, right? The main idea behind them is that your testing should make sure that you have actually touched upon different parts of the code as much as possible, right? And so the main idea is still the same over here. So the first column essentially mentions the flow name. And so for each flow, it mentions a percentage where the percentage is the percentage of the steps in the flow that are covered. And for all the steps that are missing and are not covered, their respective line numbers are mentioned over here, right? So what I'm going to do is I'm going to actually take one example and go deeper into that one. So let's see over here, there's this one particular flow that I have called search hotel, right? And I see the coverage is 76.92%. I'm not happy with that coverage because this tells me that there are certain steps that are not being covered by these sample conversations. And so I pick up like the first line number, which is 15 to 16. At this point in time, I'll go into my flow, which is this one, book hotel, right? Um, and so book hotel is the file name and the flow name is search hotel, as we saw over here, right? And line number 15 to 16 is basically this blob, right? And what this tells us is that essentially I do not have a sample conversation where, let's say if the user is trying to search for hotels and the user is also mentioning, let's say, a price range for their search, none of my sample conversations are actually covering that functionality, right? And so at this point in time, my first action item is going to be go back to my sample conversations and write a conversation which also covers that particular functionality, right? And that will just ensure that when you now try to build a data set for your fine tuning, you're covering enough number of enough number of like a good coverage of the functionality of your assistant for your model to learn from, right?
Very cool, Dutch. And we actually have a really a related and very interesting question in the chat. I'm sorry. Mohammed Salama is asking, after deploying Calm in production and users start chatting with it for some time, can I use these conversations history to fine tune the LLM? If so, can they be, how do I export them in a suitable format?
Yeah, that's a very good question. And I think so one thing that you can do is essentially, if you've deployed your model in production using just Rasa Pro, all your conversations are stored in what is known as a tracker store, essentially. Now, you can write, there are some community written scripts as well, but you can basically query that tracker store and convert conversations in there into sample conversations into a particular format. And the format that you can use is essentially this end-to-end test case format, right? The one additional step that you will have to do is ensure that you only choose the conversations that actually right now work with your assistant, right? Because you don't want to construct a data set with unsuccessful conversations, right? Because that is going to be noisy input for your model that you fine tune. And
Mm,
so what I want to do is actually filter down the conversations that are successful, right? And then use that as the first starting point for your sample conversation. So you're absolutely, and it's absolutely recommended. If you do have access to production conversations, you should be able to actually take those and convert them into sample conversations and use them.
awesome.
Awesome. So I'm gonna proceed, right? So we basically saw how to use this coverage tool, right? How to interpret the output, based on the output, what action step to take. And at this point in time, I should basically, once I've taken up all the action items, I should have a good set of my sample conversations that I now want to use for creating the data set. Now, coming on to creation of the data set, exactly. Um, what we do is a bunch of data augmentation coupled with what is known as offline knowledge distillation, right? So I'll break that down. In in practice, all of this boils down to running a single command, which is this one. So you basically say Rasa LLM fine tune, prepare data. You pass as input the all your sample conversations. My sample conversations are inside a folder called E2E underscore tests, which are over here, as you see. These are all the E2E tests, which I'm using as sample conversations, right? I'm just clicking on a few of them for you to see. And what this does actually is a bunch of stuff. So the first thing, so I'm not going to run this live because again, this is going to take some time, but I'm going to walk through each and every output of this.
And
So
just to be clear, generally, like it can take 20 minutes, 30 minutes, like it doesn't take days or hours or something like that, just for the purposes of this. Yeah.
absolutely, yes. So this is like, I mean, if let's say, for example, I'll give you a specific number. This one has around 14 sample conversations, and running this whole data generation process takes exactly around 22 minutes, not more than that. So yes, I mean, like it's totally feasible. It's not something, as Hugo said, you're gonna run it for days, which is of course gonna be painful. So once this script runs, right, what you're gonna see is a bunch of things. I'm just gonna clean up this, and so there's gonna be a folder called output that gets generated, right? And there are gonna be subfolders called a bunch of subfolders, and I'll go through one of them. So the first one that gets created is called one underscore command annotations, and I'll open just any one of them, right? Now, what has happened over here is that this is essentially a representation of one of the sample conversations. However, what has also been done is a field added to every user step, which is called LLM commands. Now, what has really happened is that behind the scenes, the sample conversation has gone through the assistant. it has used a powerful model like GPT-4 to predict the commands for every user step. And whatever command was predicted was recorded for that user step and annotated like this, right? Now, this whole step is called what is known as command annotation, right? And that's why you see it in the result folder, one underscore command annotation, right? Just to be sure that you completely understand, I'm going to also show you for this particular sample conversation, what it looked like initially. And yeah, so this was the initial sample conversation that I just took from my E2E test folder, right? And this got transformed into a command annotated conversation, right? Once you've got all of these, right, under the hood, what happens is that every user message is passed through what is known as a rephrasing module. And the rephrasing module essentially employs an LLM in the background, and it constructs by default 10 rephrasings for every user message, right? And so that is visible. I'm going to open the exact same.
Can I just ask, and this may be an obvious question to some, but not to others. So when we do computer vision, right, and we have a certain amount of data, labeled data of people's faces, or actually that's a bad example. Let's say dogs and cats or something like that, we'll do rotations and reflections and that type of stuff in order to augment the data. So is this kind of a natural language analog of what we're doing there?
Exactly. So basically, the idea behind doing rephrasings is to be able to generate different natural language variations of the same user message without having the user need to write those natural language variations, right?
Mm.
And so having these natural language variations in your data set is going to make sure that then your final fine-tuned model is able to handle or is robust to these variations, right? And so just coming back, I'm going to go through like the exact like one step of this conversation. So you had the first user step where the user said, I would like to book a car. And so what this module did was construct a bunch of rephrasings. I think these should be 10 rephrasings, essentially, if I'm not mistaken, where there's some amount of natural language variation, essentially, right? But then what it also does is it sends each of these messages to the assistant and ensures that the command that is output from the LLM is the same as the command that was output for the first user message
Mm.
or the original user message, right? Now, this ensures that if I'm going to use the rephrasings for my final data set, this step ensures that the command that I'm going to use for them is actually the correct command, right? Because if I'm doing a rephrasing of an original user message, because I'm doing this through an LLM or an in an automated way, it might create a rephrasing that actually changes the meaning of the sentence and in turn changes what should be the command predicted, actually, right? However, having this check in place under the hood ensures that for each and every rephrasing, I always know what is the correct command, right? And so what you'll see over here is that for some of the user steps, you'll see, for example, there's a key called passing rephrasings, and there's a key called failing rephrasings, right? And so what has happened in failing rephrasings is that essentially the command that would have been predicted for each of these failing rephrasings would have been different from the original commands, and hence they are separated out, right, and not included in that, and they will not be included in the final data set, right? Now you might look at it and say, well, I mean, these utterances look fine to me, why are they not being included, right? However, it basically means that your initial assistant that was built was actually not robust enough to these particular um, rephrasings, right? And I think what's also happening is that this is a particular conversation where the user is trying to first book a car and they've already told the destination. And then they say, I also need a hotel. And so it's obvious that the command that it should also take in trip destination as base as Basel, that was the destination of the car booking. But most probably that is not being picked up by the LLM when trying to send these rephrasings, right? So to zoom out further again, right? This is how we essentially construct rephrasings for each user message, right? And then finally, what happens is what you'll see in the next subfolder is the next like the step that happens under the hood. All of this data is kind of reformed into a data point which looks like a prompt and command pair, right? So if I open this .jsonl file, it's actually impossible to show you the whole every data point, but essentially what you'll see is that every data point is a JSON blob, a JSON line, and you've got one key called prompt, right? And this is the prompt that was used by the assistant in the command generator to predict the commands for every rephrasing and every user step, right? Um, and at the end, what you'll see is, so there's this full big blob of the prompt, and at the end, you will also see the command that should have been predicted. So yeah, so you'll see an output key, which is the exact command that is predicted, right? Now, if you think about it, this is like this prompt and command pair is exactly what is needed to train any model, right? Because you've got an input and you've got an output that is annotated. And you know that this output is a clean output in the sense that there is no wrong annotation really, because the steps of the recipe make sure that there are no wrong annotations, right? Um, so essentially now what happens is once you've got this master list, master data set, we also create like a train test split for you, right? And so there's going to be a subfolder called ft fine-tuning underscore splits, which has this file called train.jsonl and val.jsonl. Basically these should be coming from this master list that I'm showing you over here. And at this point in time, you're actually now ready to fine tune your model, right?
Amazing. And Daksh, would you mind just going back to the slide of the recipe?
Yes.
Just so remind us where we are. And while you're doing that, I'm actually going to post in the chat the Hugging Face data set, which is exactly the data set you just showed as well. So people can check it out themselves.
Yeah, absolutely. So yeah, so basically, if you see, the first step was ensuring system coverage for your sample conversations, right? We already did that. And then we went ahead with preparing the fine-tuning data set, right? Where we did all of this data augmentation and knowledge distillation, offline knowledge distillation to be specific, right? And the next obvious step is to actually now fine-tune a model in
Great.
order to create your fine-tuned
And
model. Yeah.
just quickly before we do that, we have another great question in the chat, which is, could you please provide us with the command that was used to produce that output folder? And are there any prerequisites to using it? I've provided the recipe. I don't know what else.
I can just paste this on the chat actually.
Great. And I'll put that in YouTube. And of course, it's in the docs as well.
Yeah.
And the prerequisites for using it are having your end-to-end tests, making sure that there's coverage and such, right?
Yeah. 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 Absolutely.
Thank you.
Awesome. Um, yeah, so coming on to, I mean, again, just a very quick recap of where we were. We have these train split and a validation split. Essentially, that's essentially what's needed to, build your or train any machine learning model. And so once you have this, what we also provide is a Jupyter notebook, a Python Jupyter notebook, to help you with the actual fine tuning, right? So what you can do actually, if you're trying this out right now, what you'll need access to is essentially One NVIDIA GPU, essentially. We recommend an A100 GPU, essentially, right? Of course, this can vary depending on the base model that you're trying to fine tune, right? What we've seen is that yes, you can even fine tune, for example, an 8 billion model on an L4 GPU, which is smaller and cheaper as well, right? So if you get hold of an L4 GPU, that's also going to be okay, right? And so if you've provisioned a machine with an A100 GPU, there are a couple of like CPU and disk requirements that we recommend, right? But of course, as you all can imagine, these things also vary with the size of the data set that you're working with and the base model that you're trying to fine tune, right? So I already have this notebook set up, for example, inside Collab, inside GCP, right? And I will just highlight essentially a couple of things that you would have to change in this notebook to make this your own, essentially, right? And then you should be able to just run it, right? So the first few steps essentially help you with the setup, in the sense making sure that you've got the right set of packages, Python packages. You don't have to change anything over there. And then there's one particular cell where you have to specify a base model that you want to fine tune, right? And this base model can really be any base model from Hugging Face. However, we recommend using models of somewhat around size of around 8 billion parameters. By default, this uses the Llama 3.1 8 billion instruct model. We've had good results with that. This is the one that I'm showing you over here, right? Fine tuning this actually keeps like cost and latency both under check and gives you reasonable accuracy. If you're aiming for even better accuracy, we absolutely recommend a Code Llama 13 billion instruct model. Um, and what we've seen is that, yes, this is a larger model and hence it will take a hit on the latency. However, the performance gains are much, much higher, right? So the amount of generalization that this model can have is much better, right? And at the end of all of this, I'll also showcase a model that we've put ourselves on Hugging Face, which is a fine-tuned model. And I'll talk a bit about that as well. So yeah, I mean, if you come back to the notebook, essentially make sure you're happy with the base model that you are using. And then the only thing that you'll have to do is make sure that this notebook has access to your train.jsonl file and val.jsonl file. And these files, again, as a reminder, these are the files that we created as part of the last step. And they should be visible inside this folder, ft_splits, right? Once you do that, you should be good to run all the steps essentially, right? What it does is it basically uses LoRa technique of, fine tuning. It uses unsloth library under the hood so that it makes training much more memory efficient. And once it is trained, you can even like run some inference on it to see how it works. But then more importantly, you can export this model to, I mean, we show you three options over here. One could be, for example, an Amazon S3 bucket. The other could be a Google bucket. Or if you are an open source person, we always encourage you to push models to Hugging Face. And so there's also instructions on how you can do that, right? And so again, I mean, this notebook on the data set for this assistant that we've created essentially takes somewhere around 20 minutes to completely run, right? I'm going to skip those steps, but this particular model, as you can see, I basically used during my run of this notebook, I'm sorry. I used this as the model repository on Hugging Face, which actually is available over here. And so this is basically a fine-tuned model already, right?
And I'll
And
link to that as well. I'm going to provide the link to that now as well. I've been keeping that sneakily on the side so that I can when it's time.
absolutely. And yeah, so essentially at this step, you're at the stage where you already have the fine-tuned model, right? You've used the data set that you generated using data augmentation and you fine-tuned the model. I would say, again, if I have to put a time span on all of this until now, all of this is feasible in a total of 1 hour, really, 20 minutes each step, really, right? And so at this point in time, what we recommend is, of course, like evaluating your model, right? That is very, very important. And so we're going to do this live in two ways. One, I'm going to have actually you go talk to that assistant. I talk to the assistant that is going to use this trained model, right? And in the background, I'm going to run some end-to-end tests, which were my sample conversations, and run those sample conversations through the assistant to see how like if those sample conversations basically pass, right? And to do that, I would essentially um, actually before that, I would also show one more thing. Sorry, I missed this. Um, Once you have this Hugging Face model, right, you would also want to deploy it, right? Because you want to serve it on a server so that you can talk to it. And what we recommend is using a VLLM framework, right? If you folks are familiar with the LLM space, VLLM is this open source framework, which is really fast and easy to use. And so again, we recommend using a GPU accelerator to do that. On this terminal, I already have this server running. However, if let's say if I was in a terminal like this, and I can actually start from scratch over here. So I'm basically SSHing right now into a compute instance, which I have hosted on my GCP. And I'm going to activate the environment, which has VLLM installed, right? And just serving this is as simple as running this command, VLLM serve, followed by the Hugging Face model repo, right? And once you hit enter, it should essentially load the model on the GPU and then run it through, right? And and I'll let this happen in the background, right? But once this is actually done, you would have to make one particular change in your assistant, right? So in your assistant now, what you need is you want to be able to actually not use OpenAI, but actually use this particular model server, right? And the way to do this in Rasa Pro 3.10 version onwards is you set the provider key to self-hosted. You give the name of the model to the name of the model that was used when running the VLLM server. So this was the whole model repo that I gave for VLLM serve. And then API base is essentially the IP address of the model server or the machine on which the model server is running. Right. So once you configure all three of these, you should basically be able to train your assistant first and then actually run inference through it. Right. Um, do you have the setup on your side or do you
So,
want?
funnily, I nearly do. What happened? The code space became inactive, and I'm having to restart my environment within it, but it should be
No
good
worries.
in about 20 seconds. So if you can hold the fort for 20
Yeah.
seconds, then we're good.
No worries. So as you all can see over here, while Hugo brings up the code space for his environment, we had run this model server with the command, right? And you can see that essentially your model server is running. While Hugo tries this out, let's actually do this ourselves as well. So I'm gonna first train the assistant, right? Because I made a change to the configuration, right? And once this gets trained, it essentially takes in the changes in the configuration and adapts to it. And once you've got it trained, I can run rasa inspect hyphen debug. This is going to bring up an inspector screen.
And I've managed to train mine and run my action server as well now, Dutch. So just so you know, I'm good to go.
Awesome. Cool. So let's just do a sanity check. If our assistant is able to talk to the model server, if ours is going to be able to talk, then Hugo is also going to be able to talk. So let's do that quick check over here. So let's say show my bookings. If I go back to my VLLM server, I can see that there was a request that was received. And yeah, the assistant responded with the correct output, right?
Very cool.
Eh, So I'll hand it over to you, Hugo.
Exactly. And
One hour
while I'm
on
starting
the
to Sheen Square, we've got a great question from someone whose handle on YouTube is the Brat, TheBrat, which I love. Their message is very kind and quite unbratty though. It's hello, what about the fine-tuned notebook? And that's actually a very good point. We did not provide the notebook, and we're not providing that notebook per se, right?
Yeah, no, actually, the notebook is available
Oh, my
on
bad.
books repository, and I can actually just send it to you or actually on. I'll just paste it on the Zoom chat. One sec.
Great, and then I'll paste it through. And Mahesh has a question: is this a feature available for Rasa Pro or Rasa Open Source? It's Rasa Pro.
Yes, it's available from Rasa Pro 3.10 onwards. So for the person who asked about the notebooks, this is the notebook that is available on a public repo called Notebooks under the Rasa HQ namespace. I pasted the link on the chat. And inside it, you should have this notebook called Command Gen Fine Tuning. This is the exact same notebook that I showed you on my collab. Hopefully that answers your question.
Incredible. Well, and they say thanks, and we say you're very welcome, Mahesh. Okay, great. So I will share my screen. I've just got so many tabs and YouTube open and code spaces and um, lucky laptops are so powerful these days. So can you see my screen?
Yes.
So what I did, just to be clear, I was in. Let me get this right. I was in this repository, and I actually started a code space. You can see how many code spaces. One called Potential Robot is clearly a robot. And I started a code space, and all I needed to do after following all the instructions in this code space was change the config.yaml, change the command generator. Now, I'm not going to show you what it looks like now because it's actually pinging what Dux has shown up. And because we're going live to the World Wide Web, we don't want to give all you kind viewers interested in Rasa, but we don't want any attacks on Dux's server essentially. But what I've done is I've trained the model as he did, and so we haven't tested this. So I'm going to inspect and then put the debug flag. Whoa, debug, no, debug. Those are the type of typos that I like to make when chatting with an assistant to see. So we should be good. Now, open in browser. That's a very nice thing about code spaces as well, where it does this for us. I'm gonna say, hey to the assistant. Hello. I'm not sure how you can help me. So I wonder, will you tell me how you can help me? I don't know. Interesting. So what do you think has happened there? Should we go back and
Yeah, let's just look at the logs for the command. If you can scroll up,
yep.
yeah, over there, it predicted a cancel flow essentially. Over there,
Yeah, interesting. So would that be because our coverage tests didn't?
yeah, it could be. So actually, yeah, so our coverage actually showed that for a particular flow called utter_skills, it wasn't that great. I mean, basically, we didn't have any sample conversation, right?
Yeah,
So the model hasn't actually learned really that particular functionality, right? And
exactly.
yeah,
So that actually isn't, it's a bug in this assistant, but it isn't a bug in this process. What we've discovered is that because of the slight lack of our coverage tests, that the assistant hasn't performed as well as we wanted. But now I say to it, what can you do? It says, so I want list flights. We'll see how it behaves with. It says it looks like I don't have any upcoming bookings, and I think I know why that is. It's because. Oh well, let me say,
Do you have your action server running? You
I thought I did. Let's have a look. Ah, no, I,
Yeah.
I don't. That's the main issue there. Do I need to restart the
Yeah,
inspector?
let's do a restart so that it is a fresh conversation because the tracker should be fresh then.
Great. So as we can see, the demo gods are actually shining. I'm not necessarily shining, but um, Rasa inspect. You got to make mistakes in public, man. You spend enough time in public and you make a lot of mistakes in public as well. So, hey. So what are my flights? Oh, great. Okay, cool. I'd like to change them. And now it's asking me, so of course, what this Rasa inspector, the interface here isn't for the end user, it's for developers like us to build, right? So we can see what's happening here. I want to fly the week after current flight. And look, so it's April 30th. Yep. It's suggesting I'm going to paste in that, and maybe I'll paste in the final open close bracket because that may be a mistake someone makes. Yes, please. Great. Now, hotel. Great. And it puts me in this flow here where, okay, first, yep, it knows I'm going to Basel. And these, as we were talking about slots before, it's essentially, it wants to know when I want to check in. So, date I arrive in Basel. See if it has a recollection of that. Um, so this is interesting. It seems to have made a slight mistake that at the moment it's giving me the 1st of May, and I think my flight's on the 4th.
Yeah.
Um, so once again, will that be because of the coverage tests?
Um, yeah, I mean, I think this is also just a function of like how much data that you've put in, right?
Oh,
Like around
yeah,
yeah.
exactly.
So for like around you've got like 14 sample conversations and we're creating like 5 rephrases under the hood. I think essentially if you're building like a production assistant, you're gonna build much more functionality. And so you're gonna have like more sample conversations and end-to-end tests.
Absolutely.
So again,
Fantastic.
I think it's just the same logic. Like for any machine learning model, the more amount of data that you have, the better it's going to perform, right? But the
Yeah,
good thing about over here is that you don't have to actually write so many different natural language variations. That is the part that is actually covered by the recipe itself, right?
exactly. Fantastic. Is there anything else you'd like to show on your screen, Dutch, or talking about evaluations or?
No, I think just like maybe showing the command data set and the model that we've put up on Hugging Face.
Exactly. So these, I've put the links to these in the chat. So maybe you can, we've already discussed these at length, but maybe you can tell us once again what's happening here, Dutch.
Yeah, absolutely. So, what we also want to promote actually in the open source is, if you think about this data set that we just created, you can think of it as really an instruction tuning data set, right? That is very popular to build models that can follow instructions, right? And so we've actually open sourced a couple of data sets over here. You can use these to build your own LLMs and see how well they can generalize. If you are, deep into the research of LLMs, you can actually build some advanced algorithms to improve the generalization capability. And also, if you go to the next tab, you go for the model. We also have the Code Llama 13B fine-tuned model up on Hugging Face. What we've seen is it actually works quite good It is trained on a separate assistant, but it actually works quite good if you try it on an assistant on which it hasn't been fine-tuned as well, right? However, having said that, we do still believe that some amount of fine-tuning will always help you, right? Because there is some amount of like domain-specific information about your conversations that always helps a model. So, but also it might also be if you try out with this model as the base model, then the amount of data that you need is much smaller,
Yeah,
right? And so we always recommend you to maybe even try out this as the base model.
absolutely. And that type of, almost horizontal scalability is super interesting. The fact that you can train on one assistant, and it scales across, which I'm really excited about. We are in the hour, so it is time to wrap up. I have actually included these there as well in the slides. I would encourage everyone to jump into these models, into the recipe, to see what you can do. Let us know on the Rasa forum. And is that rasa.com/forum? Is that right?
Yeah, I'll paste the link on that.
Okay,
Yeah, it's
great. Um, Let us know how you go. Once again, if you haven't started building with these things so much before, please do try the Rasa Pro Quick Start, bit.ly /Rasa Quick. Do check out our blog post on cutting AI assistant costs by up to nearly 80%. And don't forget about the Calm Summit, which is coming soon at the end of October. Geez, it's nearly the end of September, but that means the end of October is very, very close. And we would just like to thank you all for joining and all your great questions. We're going to get some like infinity screen stuff happening now. So I've pasted that in. I'm going to stop sharing my screen. I'd like to thank you all. If you found this interesting and think your colleagues or friends will, please do send them the YouTube link. It's going to stay on Rasa's YouTube channel. But I really do mean anything you discover or find or any fun you have with the fine tuning recipe, please do ping us in the forum and let us know. Thank you all once again for joining. And most of all, thank you, Daksh, for your expertise and generosity and wisdom and just good vibes as well.
Thanks, Hugo, for hosting this, and hopefully it was helpful for all the ones who were here. And yeah, as Hugo said, please share the word, both around the whole work and also Calm Summit. We're really looking forward to seeing you all over there.
And so excited to see what you do with all this really exciting, incredible new technology. Awesome. All right.
Awesome. Thanks, everyone.
And scene. Awesome, man. Let me show you.